Hola, ¿cómo está? We are talking about prisms and cylinders and their surface area. Unit 7, lesson 6, so we're still talking about geometry. We're still talking about polygons, polyhedron in general, and cylinders as well. So first, surface area of a prism. So you'll notice that there's a formula here, 2b plus ph. We can't use that formula unless we know what all those letters stand for. So first of all, SA, surface area, the total combined area of a figure's outer surfaces. Think of it like wrapping paper, okay? If you were going to wrap a present, how much wrapping paper would it take? How much would you have to put on the outside of the shape in order to cover the surface? So there are two bases on a prism. So we need 2 times B. B is the area of the base. Notice it's not a length, it's an area. So we have to find the area of the base in order to do 2 times the area of the base. We also need capital P, which is the perimeter of the base. And we need capital H, which is the height of the prism. So let's take a look right here at this figure. What would we call this? We would call this, because it's got rectangular bases and all of the sides are rectangles, we would call it a rectangular prism. Prism because all of the sides are rectangles, and rectangular because the two now yellow bases are rectangles. Then we also need, right, so area of the base is one of the things we're going to have to find. Perimeter of the base. So once you've colored in the bases yellow, the perimeter of the base would be the distance around the base, the length of the 4 edges that it takes to go around the base. You can either look at the one on the top or the one on the bottom. Doesn't matter. Remember, they had to be congruent. So if that one doesn't have any labels, perimeter of the base could also be this one down here. Last but not least is height. And you'll notice it's capital H, height of the prism. That is the height as in how far is it from one base to the other base. Height is not necessarily up and down. So we're going to take a look at some that have both properties. First, we need capital B, the area of the base. So the area of the base, it's a rectangle, so we're going to do length times width. The area of the base in this case is going to be 8 times 30, length times width. So that is 240 feet squared. Second thing we need is the perimeter of the base. So the perimeter of the base, it's a rectangle, so we're going to do 2L plus 2W, 2 times the 8 plus 2 times the 30. We've got 2 sides that are 8, 2 sides that are 30. Our perimeter is going to be 16 plus 60, or a perimeter of 76 feet. The third and final piece of information that we need to collect is height, capital H, height of the prism. And that one is right there, 18 feet. Don't need to do anything except identify it. If you want to, we can say H equals 18 feet so that we have numbers to pull. Now, there was a formula, right, for surface area of a prism. In order to use that formula, we needed area of the base, perimeter of the base, and height of the prism. We've got all those things. So here we go, 2b plus ph. The surface area is 2 times the area of the base, which we found to be 240, plus the perimeter, 76, times the height, 18. There's 2 multiplications here separated by an addition. So I can do the first multiplication, 480, and the second multiplication, 1368, separated by addition. Remember, according to the order of operation, multiplication comes before addition. And last, I'm going to add them together, 1,848 feet squared, and that would be the surface area of the whole prism. So we collect a lot of information so that we can use the surface area formula. Notice on a rectangular prism that the front and back are congruent, top and bottom are congruent, and the left and right are congruent. This is true of all rectangular prisms. Now, how do I know the next one's a triangular prism? Well, it has triangular bases, a triangle on the top and a triangle on the bottom. They're congruent and they're opposite, right? One's on the top and one's on the bottom. All the other sides are not triangles. So the fact that it is made up of exactly 2 triangles and everything else is a rectangle makes it a triangular prism. So first, we're going to start off just like we did for the one before it with area of the base. Notice those yellow ones? Area of the base, if it's a triangle, is 1/2 BH. Notice I've gone back to lowercase because I'm talking about the 2-dimensional flat yellow sides. So the area of the base can be 1/2. What are B and H? Now I'm going to tell you guys, You have to look at this one quite carefully because down here, if I start marking off the perimeter, you'll notice inside that there is a line with a little right angle symbol. That tells us that that little line in there, which is labeled 4 centimeters, that's the height of the yellow. And that right angle there shows me that I need the 6 at the bottom and I need the 4 centimeters that goes up the middle. So that is my lowercase h and the 6 is my lowercase b. So times 6 times 4. If you draw the triangle so that it is no longer in the design, you will see that 4 is this, the line up the middle, 6 is that side along the bottom. So 1/2 times 6 times 4 would be 3 times 4, or an area of 12 centimeters squared. Now the perimeter, there really isn't a formula to follow for perimeter of a triangle. You're just going to add up the 6, and then this side is 5, and this side is also 5. If you look along the top, 6 plus 5 plus 5, the perimeter is going to be 16 centimeters. And then last but not least is the height. The height of the prism is the distance from one base to the other. The base on the top to the base on the bottom, 4 centimeters would be your height. If you want to write it down, h equals 4 centimeters. Now I've collected the 3 pieces of information that I needed. I'm going to write my surface area formula. In order to find the surface area, I need 2 bases. They are each 12, plus the perimeter, which was 16, times the height of the prism, which is 4. So that is 24 plus, now 16 times 4 is 64. Added to the 24, a surface area of 88 centimeters squared. Not terrible, but you do have to break it down and be pretty systematic. I need to do step 1, area of the base. Step 2, perimeter of the base. Step 3, what's the height? And then last, plug those into your formula. So if we look at the back, we're going to look at a cylinder. Now, on the front, if I go back to look at the front quickly, we did have B was the area of the base. Well, when it's a cylinder, your base is a circle. C is the circumference of the base. Well, circumference is practically the same as perimeter. And H is the height of the cylinder. So I'm still finding the same 3 things, but you'll notice the formula is different. 2 pi r squared plus 2 pi r h. So I'm going to copy that here. It is a cylinder. And the surface area is 2 pi r squared plus 2 pi r h. Now, where the heck does that come from? Well, there are 2 bases, right? And they're both circles. So I've got a circle on the top and I've got a circle on the bottom. So those are my 2 bases. A circle is pi r squared plus 2 pi r h. Well, the circumference, or around, let me get the right color here, or around the base is 2 pi r. That's your circumference. And then your height is the same thing. It's the distance from the base to the other base, or the distance from the top to the bottom for height. So it is practically the same set of steps. The major difference is that we have to use formulas for circles because our bases are now circles. Instead of having a perimeter, we now have a circumference because it's round. All right, so let's collect our information. The area of the base, or pi r squared, right, that's our area of the base, is going to be pi. Now I'll switch this to approximately. 3.14 times the radius, 8 squared. So that is 3.14 times 64. And if I'm doing 3.14 times 64, oh, there's 2 of them, right? So when I get over here to surface area, I am going to have to do 2 of them. But my area of the base, 3.14 times 64, is approximately 200.96. So that's my area of the base. I also need the perimeter, or circumference. The circumference is 2 pi r. So I'm going to do 2 times 3.14 times the radius 8. So 2 times 3.14 times 8, that is 50.24. The first one, area of the base, would have been feet squared. The second one, circumference, would have just been feet. And last, we were able to identify that the height was 9 feet. All right. Now, if you are choosing to go this route, You're going to have to do 2 times the area of the base plus the circumference times the height. It's the same concept as it was on the front. Nothing significantly different. 2, the area of the base is 200.96 plus circumference 50.24 times the height, which was 9. Surface area, I do need to switch that though to approximately because I did round. I used 3.14. So that's going to be 401.92 plus 452.16. So the surface area is approximately 854.08 feet squared. Now, me personally, I do not do cylinders the way I do prisms. If I am going to find the surface area of a cylinder, I am going to use the formula that is right up here, 2 times 3.14 times 8 squared plus 2 times 3.14 times 8 times 9. I fill in each individual piece into one long formula. Then I do the 8 squared because exponents come first. And then you're going to like this part because this actually saves you a bunch of work. Numbers that get multiplied, separated by addition, and then more numbers that get multiplied. 2 times 3.14 times 64, that's going to be 401.92. That should look familiar. Plus 2 times 3.14 times 8 times 9. There's your 452.16, also very familiar. And you still get a surface area of 854.08 feet squared. The difference, this took a heck of a lot less writing and work than finding the area of the base, finding the circumference, then plugging it into the surface area formula. Strongly suggest memorizing that surface area formula, 2 pi r squared plus 2 pi r h. Last but not least in this area, name the figure. So the shape in the front is a trapezoid. So this would be a trapezoid in the front, and then it's kind of hard to see once you color the front, but there's also a trapezoid in the back. This is a trapezoidal prism. So the trapezoid in the front is the one that you would find the area of, and then you would do the perimeter of that trapezoid, 5, 2, 5, and 8. And last but not least, the height of the prism. Now, this is what makes this one different. You have a base in the front, and then you have another base in the back. So the height of the prism actually goes from front to back. So in this one, the height is only 3 meters. Capital H, remember. This 4 meters is the height of the trapezoid, where the 3 meters is the height of the overall prism. So if I'm going to do the same formula that I did before, area of the base, I need the one for trapezoid. Base 1 plus base 2, I only want half of it. And notice that's a lowercase h. We're only taking our information from the yellow trapezoid. 1/2, 2 plus 8, and the height of the trapezoid is 4. The 2 across the top, the 8 across the bottom. 1/2 times 10 times 4, which makes an area of the base of 20 meters squared. I also need the perimeter. There's no specific formula, so I'm going to add the 5, the 2, the 5, and the 8, which gives me a perimeter of 20 meters, and I've got my capital H for my height. We need the surface area formula. This is a prism, so we go back to that 2b plus ph. Surface area, 2 times the base. So the base was 20 plus the perimeter, 20 times the height, 3. Hardest thing on this problem is that height of 3 that goes from the front to the back, because the height is always the distance between the bases. So I'm going to have 40 plus 60 for an overall surface area of 100 meters squared. Last but not least, we have a surface area question down here. It says, determine the shape of the base. Remember, shapes are not always resting on their base. Calculate the area of the base, calculate the perimeter of the base, find the height of the prism, the distance between the two bases. In this case, it was from front to back, and substitute into the correct formula and solve. But what if one of those dimensions is missing? If a dimension is missing, you have to be given the surface area in order to find the missing dimension. So I'm going to do everything that I can. Do I know the base. Do I know the area of the base? Well, this one is sort of a hidden base. I kind of can't see this thing down here, which would be your base. And that would be area of the base, length times width. That would be a 5 times 13. So the area of the base, 13 times 5 is 65 centimeters squared. Then I need to say, well, can I do the perimeter? Well, sure, I can do the perimeter. It would be 13, 5, 13, 5, or perimeter, which would be 2 times the 13 plus 2 times the 5, 26 plus 10. Perimeter would be 36. And the thing I don't know this time is, oh, sorry, I went off the screen a little bit. Thing I don't know is the height. I don't know the height of the prism from the base on the top to the base on the bottom. So I will start in this case by emptying my hand of a whole bunch of pen caps. Surface area, 2 times the area of the base plus the perimeter times the height. I know the surface area. We were given it. It's 382. So on the left side that normally says surface area, I'm going to substitute the 382. 2 times the area of the base plus the perimeter times this unknown height. All right, how do I solve it? Two-step equation. 2 times 65. 2 times 65 is going to be 130 plus 36x. I need to get rid of any addition or subtraction on both sides first. Now I've got 36 times x, that's multiplication. I'm going to use the inverse, divide both sides by 36, and I'm going to get 7 equals h. So that tells me if the area of the base is 65 and the perimeter is 36, the only way to get 382 is with a height of 7 centimeters. H has to be 7 centimeters. This is a lot of information to take in. It's going to take a lot of practice and a lot of flexibility because the area of the base changes when the shape of the base changes.